Layer 2, the layer which is trying to solve the blockchain trilemma. It's also known as the scalability layer. And currently, we are located at the level of the house, which is built on top of the foundation. If we think about layer 2, we can also think about terms like off-chain, snark, zero knowledge, polygon, scalability, sidechain, or optimistic rollups. I know that some of these words are new to you, but we'll explain some of them in the further slides. So what is actually in layer 2? First of all, we have sidechains. Sidechains are the independent blockchains which are built on top the layer 1 blockchains, like, for example, Bitcoin or Ethereum. What is important is that they have their own consensus mechanisms, so basically a set of rules and requirements for the creation of new blocks. Another important thing are rollups. These are the solutions that are grouping transactions together that are processed off-chain, and then they are going back to the main chain as a single output, single transaction. And as you can see, the rollups is actually the process of executing and compiling a batch of transactions off-chain, and then it's sending their output back to the main chain as a single transaction. So what does it mean? Let's imagine a bag. And what we can do is to fill that bag with lots of transactions, hundreds or thousands of transactions. And we take them from the main chain, so let's say from Ethereum. We take that bag into layer 2, so from layer 1 we go one level higher, where all these transactions can be processed in a much faster way and at a lower cost. Once we are done with processing, we can roll all of them up in a single output, which then will be sent back to the underlying blockchain. Another term that you might have heard are zero knowledge proofs. It is a method by which one party, one person, device can prove to another that a given statement is true, but without giving any explanation, without giving any background of how they figured out that particular solution or that they know that the statement is true. Well, how can you actually do that? We can use an example of a game I'm sure you already know. Where is Wall-E? Where is Wall-E is basically a set of images, pictures filled with people, shapes, colors. It's like very crowded. And your goal here as a user is to find Wall-E within that crowd. So if we look at this image, we can find Wall-E in the center of the picture. What does it have to do with the zero knowledge proofs though? Well, let's now imagine that we want to prove that we know where Wall-E is, but without explaining how did we manage to find him. So let's imagine that we have a piece of paper that we will put on top of the picture with Where is Wall-E game. And what we will do is that we will just cut a hole in that paper, which will show Wall-E himself. So what we'll do is to show that, okay, I know where Wall-E is. And you can clearly see that this is Wall-E. But what we're not doing is that we're not explaining how did we manage to find him. I'm not saying that he is surrounded by these people, that the water is on top and there are some other elements around him. So as you can see, I can easily prove that I know where is Wall-E without giving any additional context. And this is pretty important in terms of blockchains, because once we computed something off-chain, so in the layer 2, we can then send the result back to the main chain without all the information that we needed to actually perform the processing and the computation. This allows layer 1 to be much faster and also to operate at a lower cost, because the more information, the higher the cost. So if we provide less information and only go back with the most crucial information, which is the output, the result, the cost drops down. So let's actually recap what goes on in layer 2. It addresses the scalability issue. Thanks to solutions like Rollups and zero-knowledge proofs, the heavy computations can be moved off-chain to the sidechain to optimize the entire process. Once those transactions are computed off the main chain, they can be sent back to the layer 1, to blockchains like Bitcoin or Ethereum, where they can validate the single output. This is increasing the computational capacity of layer 1. So, as this is getting quite complex, and frankly speaking, layer 2 is being actively developed by different companies that are building various solutions to address the scalability issue, we won't really go into the advanced details. You can think of it as basically different companies building the house, different houses on top of the foundation. And each company is using a different component, different material. Some of them are using bamboo, the other ones using bricks, some are using wood, and they are all testing what is the best solution, what is the best option. And the process there is really complicated. However, if you would like to learn more about layers 2, then head to the Go Deeper with Web3 Tech module, where we will have additional content on how layers 2 work with some specific examples of the solutions that are being built.